Right, welcome back everyone to session number 22 of this CSEC Quadratics course. Right, so we are actually to the end of the quadratics, right? Well, on the tail end of it, because now you could actually answer almost any question that comes your way in CSEC Quadratics. The only thing that is missing, they only have two, maybe three things that are missing. One is what we call the quadratic formula. Yeah. Two, I need to show you all how to find the roots using factorization, which you know how to do already, but I didn't formalize it. Right? So factorize to find roots. Factorize to find roots. And the last thing that I want to talk to you all about is the formula method. Formula method for vertex form. Right? Oh, and also I have to talk about difference of two squares as well. Difference of two squares. Right? So this might take us probably two more videos again, but we'll be done with it. Right? So in this session, what I want to do, hopefully get through two sketches using these steps here. Right? So fully using these steps. So you can always take a screenshot of the steps here. Right? But we are going to sketch a curve now using vertex form. Now, if you remember, see if you can pause the video and remember what is the name of a quadratic curve, the official name for it. Right? As I write this question. Right? So if it is anybody remember it, the name of a quadratic curve is a parabola. Right? To sketch the curve with equation. Sketch the curve with equation 1. All right, let's start off with an easy one. Y. So let's say we are given this in vertex form, right? Y is equal to 2 into x plus 3 squared minus 2 into x plus 4 squared minus 18. Good. So we'll go with this one here. So we know how to get to this form. You complete the square, or you could use the method. So we didn't do yet, formula method and expand and compare, and you can put it in this form here. That's you know how to do this, right? Now from this here, what we have to do is a few different things. The first one is that you need to get the nature of the curve, right? So since a is greater than 2, since a is greater than 0, my bad, greater than 0, right? Because a is positive, so rather than saying greater than 0, we could say since a is positive, and you could use this symbol, a plus VE, that means positive, right? Since a is positive, the curve, the curve is a minimum point. The curve has a minimum point. So the graph looks something like this here, right? More like this. Right, remember it looks like a V but with a curve underneath it, right? Part B. Now that we know what type of vertex it have, let's find the coordinates of the vertex. Right, so the coordinates of the vertex, right, again from the list that we have up here, that formula is minus HK. And I would have done this in the last session, so feel free to check it out, right? So whatever H is, right, you do the opposite of, that's what this means, do the opposite of the sign. This is plus 4, so minus H means minus 4, and K is negative 18. So these are the coordinates of the vertex. So the lowest point of the vertex here is minus 4, minus 18. And the vertex in this case is a minimum point. And this is why we call this vertex form, because you could get things for the vertex off of it. The next step now is you want to find the y-intercept. So remember the y-intercept occurs at x is equal to 0. It occurs on the y-axis. This is the y-intercept. So we want to get what that y-intercept is. So since the y-intercept occurs at x is equal to 0, you just take x is 0 and solve for y. So our equation is y is equal to 2 into 0, right? So 2 into 0 plus 4 squared minus 18. Again, look at this. We use this equation, we replace x with 0. So this now becomes 2 into 4 squared is 16 minus 18. So this will give us 32 minus 18. Now, I will always tell you all, try your best to stay away from calculators for easy things like this because they are easy numbers and you end up using a calculator too often and wasting time, right? 32 minus 18 is obviously 14. So this is your y-intercept. So therefore, the y-intercept is equal to 14. If they ask you for the coordinates of the y-intercept, it is 0, 14. Good. Part D now. But part D, we need to find the roots. Now, where do the roots occur? Right? As we talked about in session 13 and 14, the roots occur at y is equal to 0. So you let y be equal to 0, right? So let y be equal to 0 and solve for x as the steps above told you. So in that equation, when y is equal to 0, it becomes 0 is equal to this. Or we could write that as 2 into x plus 4 squared minus 18 is equal to 0, since y is 0. Now we have to solve for x because the roots are x values. So first you transpose the 18, that means you have to add 18 to both sides. So if you add an 18 to both sides, 0 plus 18 is 18, right? Then now, you have two ways you can do this. You can divide throughout by 2, right? Actually, you should divide throughout by 2 because this is multiply by 2. So divide both sides by 2. So this will give us 18 over 2 is 9. And now we have to get to x, right? This is square. So for us to undo this square, you need to take the square root of both sides. Now, if I take the square root of this side, the square root and the square will cancel off to just give me x plus 4. Yeah? We actually don't need to put that in brackets anymore as well. Because the square and the square cancel off, but whatever you do to one side, you have to do to the next side. This becomes the square root of 9. Now, if we are doing the square root of 9, you have to be very careful here. Now, the square root of 9 is not just 3 alone. Right? Remember, the square root of 9 is actually negative 3 as well, because negative 3 by negative 3 is equal to positive 9 too. So the square root of 9, whenever you take the square root from now on in this section, you attach plus or minus because you have two possible answers for the square root of 9. Because the square root of 9 is 3 or negative 3. Yeah? So now what we get here now is this. So now what we have here, when we transpose the 4, because we have to solve for x, x is equal to minus 4 plus or minus 3. Now what does this mean? Remember, typically when we had a graph, we had two roots. So you had one root here and one root here. This is what this means, right? So what this tells us is that we have two roots. x1, we call this the first root, is minus 4 plus 3. Negative 4 plus 3 is negative 1. Or x2 is negative 4 minus 3. Negative 4 minus 3, which is negative 7. So therefore, the roots are x negative 1 and x is equal to negative 7. So these are your two roots now. So our graph that we had here but disappeared just a moment ago, right? These are both negative numbers, right? Negative 7 is further from 0 and negative 1 is here. These are your two roots. So your graph will look something like this. Maybe, we don't know as yet, right? So it has the partial numbers, right? So these are your roots here. Now this is a quick sketch, but we want our official sketch now. So what I want to do, I want to get everything all together. And let's look at this here, right? So first of all, when we sketch in this curve, right, and I'll sketch the curve here, right? When we sketch in this curve, you first need to check your roots, right? So you want to see what type of graph you have to draw. Do you want to draw a graph where you have both sides here, or do you want where you have only one side here, one side here? How you know is if the values are both positive, both negative, or one positive, one negative, if the roots are that. These roots are both negative, so you don't need this whole side here. You could draw it still, right? So let me leave this up here for now, but you don't need this whole side now. Now, the next thing is, I know both of my values are here and here, somewhere around there, but let's not mark any positions. Next thing is your y-intercept. Where's your y-intercept? Our y-intercept is at 14, which means that the graph coming down here, coming up to here and cutting at 14. All right, now if our 14 is somewhere around here, you have to kind of picture where your minimum point is as well, right? Our minimum point occurs at -4, -18. So which means that the y value of the minimum point is a little bit lower than the y-intercept, right? So keep that in mind as you sketch this curve, and let's see how this is looking now. So we sketch our curve, we cut here, you go down a little bit lower, you come up and you try to cut the graph a little bit closer to zero than the minimum point was. Now this is not perfect, far from perfect, but you all will have to make a smoother curve than this, right? I still learning how to get used to this tablet, but you get the general idea. Now, this is -7. This is -1. Always put 0 with your graph. This is y. This is x, right? Now, it's putting the 0 there is fine, but you really should put the 0 on one side or the other, right? So this is here, 2 roots. Your minimum x value is here, right? And that minimum x value is, if we scroll back up, -4, it's between -1 and -7. And this number here is -18. Writing those values there. -4, -18. And lastly, your y-intercept is at 14. Yeah? And that's a sketch. A sketch does not have to be drawn to scale. And that's important. A lot of people don't note that. It don't have to be drawn to scale. But I mean, use a ruler. Use a ruler, use a pencil. Never use a pen to sketch these curves. All right, so this is how we sketch our curve using this here. All right, very, very, very important. So it's just something that I just want to make sure that you all know how to do. It's a nice, easy skill, right? And nothing too bad there to do with this here. All right, so this here is your curve sketching tutorial and how we get it after we complete the square. All right, now in CSEC, a lot of questions are not going to come. When these questions come, they tell you to sketch the curve, but you might have to show everything. Right? They will usually tell you showing clearly the roots or showing clearly the y-intercept and the roots or something like that, or the minimum point, right? And then they will ask you what is the minimum value. Now the last thing you can add in for some flair here, even if they don't ask you, add in the axis of symmetry. Right? Now remember, your axis of symmetry is whatever number it passes showing the minimum point, the x value is equal to -4. And you can always write that in as a part E. The axis of symmetry is x is equal to -4. Yeah. And if the question asks you for the minimum value of the function, the minimum value of the function is just the y minimum value, which is key, right? Which in this case is -18. Yeah, that's the minimum value of the function. So this is how we sketch a curve. Feel free to pause the video, go over the video. If you have any questions, you can always write in the comment section, right? You now have this video here to help you sketch a curve, and this is what we were building up to all this time. Good. So we are at the end of this video. So, and you notice how long it took, and it's mostly because I took my time to explain how we get each one of the components. So I will do one more video on curve sketching for you all to show you how to sketch a maximum point curve like this. All right, and most likely I'm going to have one root on either side, so you can see how to do different types of curves. But this is it, right? So this is it for CSEC maths, other than the 4 things I talked about, I believe up here. Yeah, these 4 things here. These are like sideline things. You don't need to know them, except the quadratic formula, but that is given in the formula sheet, right? But we will still go over it, where it came from, and how to use it to find the roots. Similarly, how to find the roots by factorization. So basically, we only have a few more videos again, and then the whole series will be finished. So with that being said, that is it for this video, and I will see you all in the next video to do one more example on how to sketch a curve. Right, so that's it for now, and until the next time, Stay safe. Take care.